Hi everyone, welcome to Learning Space. I'm Nicole Gallucci. I am postdoc with the CosmoQuest Citizen Science Project. Joining me this week is my co-host Georgia Bracey.
Hello.
Hello. Georgia is the
everybody.
formal education lead for CosmoQuest, and we have with us Jonathan Roberts.
Hey there.
Who is a postdoc and also one of the recent winners of the Space App Challenge, which we'll be talking about in a few minutes. First, I actually put together a very last-minute hands-on demo. Today I've been following the story of a high school girl in Florida by the name of Kiara Wilmot, who has been arrested and expelled for doing a somewhat dangerous science experiment on her school grounds. And there's a lot of speculation and stuff surrounding the story, people saying a lot of things. But from what I can tell, it seems like, she did something not terribly good, not something worthy of a felony. And, official science experiment or not, I say, play with the science, let's go. And to do that, I'm going to make a little explosion in here, but try and demonstrate some proper safety techniques while I do it. So first of all, I've got my safety goggles. So if you're going to play with anything that's going to make a boom, wear safety goggles.
Because they're cool looking.
Very fetching.
They look almost as cool as my Google Glass is going to look, right?
Exactly.
Okay, a little dorky.
Getting ready for those, yes.
I'm getting ready for that, that's it. And I have one of my favorite substances to play with in a plastic bucket here. So I have some dry ice. Ooh.
Very nice.
Yes. So you can do lots of things with dry ice that demonstrate how the pressure changes when something goes from a solid to a gaseous form. And there are various ways of doing that safely and unsafely. I've been around at least one very unsafe demonstration. Don't ever use glass. Don't ever use glass when you do this. But I did find a little, we have a whole bunch of these plastic film canisters. Do you guys remember film?
They are hard to find.
I know you guys do, but I'm sure somebody watching is like,
they're so cool and useful, and they are really rare. So.
You can keep a lot of little SD cards in that container.
Ooh, that's brilliant. I never thought of that. Don't tell Dawn.
We have a lot of these.
Yeah, we have a lot of these here in the. I live here in the STEM Resource Center on campus, and so we have a lot of odds and ends like that you can play with. And I have a glove. I have this nice little rubber glove thing. You don't want to touch dry ice with your skin. That makes for badness too. And you can see what happens when you take a little piece of dry ice. The problem with the gloves is, of course, hard to pick things up. And I use this when I do demonstrations of what comets are made of. It's really fun to mash this up into a powder, add water and dirt, and you have a comet. It actually outgasses just like a comet would. So can you see that? I don't know how good the resolution is.
Yeah, you can see that.
Yeah.
So hopefully on the YouTube stream you'll be able to see that too. And so it's outgassing, and I'm going to put it in the little plastic container and put the lid on it and just, set it aside. And see what happens. But I also have
later.
Sean came over with this lovely gooey liquid, which I'm pretty sure is soap and water.
It looks green. Is it green?
It's green.
Greenish.
It is green.
Okay.
I think it's soap and water, but you can also, when I'm not doing comets, I usually have a little bottle of water on the side, and I'll drop some dry ice in the water, and you get stereotypical picture of science. So as it's outgassing, you get the gas and also some crazy bubbles. Because there's a lot more soap in here than I realized there was in the first place. So you're showing changes of, this is why I have a big plastic tray too. You're showing a change in the state of matter from solid to gas. This is called sublimation. Teach this to your third graders. They will go home and tell their parents and be very proud of the word they learned. And you get your stereotypical picture of science right here. You can put a little bit of dry ice in drinks, just don't actually drink it for that cool smoky effect. A lot of people do that around Halloween, and this is actually going to bubble over, isn't it?
It's not bubbling over too quickly, though.
No, I think Sean measured out the right amount here.
I don't know.
So dry ice, fun to play with, but be safe, goggles, glass. And if you're going to do an explosion, do a tiny little plastic explosion like this guy. So we'll sit here and wait. Oh, I can feel how cold the plastic is. We'll wait for that to explode. I'm sure that'll scare the pants off of me at some point. I'm going to leave my safety goggles on until that happens. I don't actually
You have it aimed properly.
I do, as I'm holding this piece and pointing the other piece away from my face.
Okay.
So, you know.
We'll look forward to that, yes.
Be curious, play around, you know, do science even when it's not an official science experiment. Oh gosh, it's really cold. But be safe when you're doing it. I think that's the lesson I want people to come away with. What ends up happening with the story with the Florida teenager, I don't know what's going to end up happening, but there you go. I will share a link about that in the comments. And I'm going to set my film canister over here. I'm sure the mic will pick it up. So thank you to Dawn and Sean for getting me dry ice and bubbles. So, you can find dry ice in a grocery store usually. That's where I've always found it.
I'm impressed that they got the dry ice that quickly.
Yeah.
They did. Well, of course, we're at a science building, right? So
I know, but
Every
still.
science building has dry ice.
we have a
You
cooler.
gotta, like, go upstairs and things.
We were told we could go and get it from ice cream shops.
Yes,
Ice
that's
cream
another
shops
place.
have dry ice. That's a good place to get dry ice.
That's another place to get it too. Yeah.
In our case, we were using it to make a cosmic ray detector.
Ooh, you want to tell us about that? That sounds cool.
Yeah.
Oh, how do you do that?
So actually, it's surprisingly simple. So what you do is you get a sheet of metal, and you put it on top of a tray that's got dry ice in it, and you turn a big plastic box upside down over the top. Now, inside that box, you put a sheet of fabric on the bottom and a sheet of fabric on the top soaked in alcohol. And what happens is the alcohol gets into the air inside the box, and the fact that you've got the dry ice on the bottom cools it down, so you get this kind of super condensed gas inside, but it's still transparent. And then when a cosmic ray comes through, just like an airplane going through the air, it causes condensation. So it creates a vapor trail for the cosmic ray in the air, and you can actually see cosmic rays passing through the box. It takes about 5 minutes for the gas to condense to that level, but then you can see all these little cosmic rays coming through. And if you happen to get your hands on an actual radioactive source, you can stick it in, and it looks like a big spiky Christmas tree because all the cosmic rays, all the radiation goes at a given distance and then stops. So if you have like an alpha source, it goes like 2 centimeters, and then it just stops.
Cool.
You see all the little vapor trails coming off. It's really cool.
Okay, we're doing that.
Yeah.
We're totally going to do that.
Do we have the radioactive source here?
Wow, went over that. But we do have cosmic rays. Maybe
Everyone
less
has
so in the
cosmic rays.
basement. But
Cosmic rays are totally democratic. They'll hit you wherever you are.
yes, they will. Even in my basement office.
They will, even in your basement office.
So is that a cloud chamber? Is that what they?
Yeah.
Is that another? Okay, I've
That's a
heard
homemade cloud chamber.
that. Never made one though, but same thing. Okay.
If you have a link for how to do that,
Yeah, I think we knocked together, we put together a proper thing for it because it was done for a science for non-scientists course here at NYU, so we did it with all of the undergrads.
cool.
I'll find the link and pass it over.
Excellent, excellent. So that'll be an even more impressive demo. I'm out of dry ice. And everything.
Yeah, that might be one you want to get up and running well before you start.
Yeah. I'm gonna put a bigger chunk in. Woo! Science. All right. So let's talk about the main point of the main topic of the show. We brought you on to talk about Space App Challenge,
Yes.
which went down. Oh shoot.
Oh, you don't want to hear that in your science experiment. That's not what you want.
Actually, you can feel
Wow.
it too.
Okay, that's pretty great.
That's more what I had in mind.
I'm getting distracted. This happens. Okay,
Well, this is every day for us.
This is every day. Welcome to science. Oh, and before I get distracted again, I want to remind everyone watching, if you want to comment or ask a question, you can do that on the YouTube channel. We're watching those comments. You can do it on the event page. We're watching those comments. If you're watching anywhere else and want to use Twitter, use the hashtag #LearningsSpace and go ahead and do a comment. Send us a comment or a question, and we will try and include that on the show. Guido Bubra just said that Brian Cox did a demonstration of a cloud chamber in his last TV series, so it may have been something similar as well. So
Cool.
Homemade materials doing science. I love it. Okay, so we're going to talk about the Space App Challenge, which happened on April 20th and 21st.
Yes.
Can you tell us a little bit about what that whole thing is?
Yeah, so basically what they did was NASA put up a whole load of challenges for people to take on. And it was a worldwide event. They say about over 9,000 people got involved. So it's the largest hackathon ever run. And the plan is that people were to, in the course of those 2 days, they would take on one of the challenges, see how far they got, and present their solutions on the Sunday. And this took place kind of virtually, but also in specific locations. So here in New York, there's a big co-working space called Alley NYC, and we all went along there. There's like a few hundred people were at that, and we won the New York edition of the Space Apps Challenge. But then there was also like an Abu Dhabi winner. There were some winners in Exeter in the UK. So there's a whole load of different local winners, and all the local winners are now being put forward into a global challenge.
Okay.
And the deadline for all the global challenges to be submitted properly is midnight GMT, which is in 40 minutes.
And you're here.
We're done.
You guys must
We're
be
done.
done.
We're good.
You guys
We're
good.
good.
Okay, good. I don't
Was
want
a group of you working on this, Jonathan, then?
Yes, I didn't know
How
any
many?
of the guys before I turned up. I just sent an email around to the local email list on the Friday saying I was a postdoc at NYU and I was interested in doing one of the challenges. Over the course of the Saturday, we picked up a total of 7 guys to work on the project, each of whom had different specialities, but none of them had a science background. They were all, like, one was a grad student at NYU in computer science, another guy has a big data background, specialist in doing data architecture for enterprise scale companies, another couple of guys who like web design. So it was a very disparate group of guys. 2 of them had worked together before, but the rest of us had all met each other for the first time. And we sat down and basically hammered out a solution to one of the challenges. We had a working prototype by like 9 o'clock that night. So unlike all the horror stories I've heard about hackathons, we went to bed at like 11:30, and we got in at 10:30 the following day, and we were done. I know.
That's not fun.
No, that sounds
all
normal
night.
somehow.
We got in at like 10:30 the following day, and all the breakfast food had been eaten by the people who were sleeping there overnight.
Wow.
So in other words, like people in the corridors, people in the chairs, you know.
So
was
which
pretty great.
challenge in particular? There were several challenges that were issued. Everything from there's some citizen science type projects that were done involving greenhouses, involving asteroid dynamics. What challenge did you guys pick up?
So we took on something called MySpace Cal. So the challenge was that there was a space calendar which tracks telescopes and what telescopes are looking at. So there's a whole load of telescopes up in space, all looking at different objects. But there's no one place to go to find out where they're all looking at any given time. And the European Space Agency had an earlier version of that run by the guys on the Integral telescope.
Okay.
But it didn't really work. And they wanted a new version that was up to date and was updated like every day, so it was all keeping track of everything accurately. And we put it together. But we decided not just to do a calendar, we wanted to actually show where all the telescopes were looking at any given time. So it's actually a visual map of the galaxy and the space around the galaxy, showing where all the telescopes are looking on any given day.
I can do a share of that.
There we go. So yes, there it is. So that is our galaxy. That's the Milky Way, where we are. And conveniently, astronomers use the galaxy for their coordinate system. So just like on Earth we have an equator, on the galaxy, the kind of galactic equator is the line along the middle. So as you go up and down from that, you increase the coordinates. And as you go left and right from the middle of that, you increase your coordinates. So it's actually a set of axes. So it tells you where you are. And then each of the dots is a different observation by a telescope. So the red dots that you can see there are the Swift telescope. The dark blue dots are Herschel. The yellow dots are Integral. And you can see a whole list of the telescopes that we've got integrated into the app up at the top. And if you click those, then you can do that.
Spitzer, I see Hubble.
Yeah, and so this is for this. It automatically loads up yesterday and tomorrow. So we have future dates as well.
Okay.
And then if you double-click on the background map, you will zoom in. So you can zoom into the galactic center. Yeah, there you go. Double-click will zoom back out again. That was the galactic center.
That's the galactic center. That's the galactic center.
Yeah, so there's the galactic
This is
center.
Swift actually looking right at Sagittarius Star.
It is, right at the very center of our galaxy.
And that's a picture.
That's not a picture of Sagittarius Star. That's the default picture we load when there isn't actually an image. Unfortunately, we don't have an image of the black hole at the center of our galaxy to look
We have
at.
some very pretty images of the space around it.
You do. If you
Definitely not with
double-click
Swift.
there's a bunch more in there, but we scrape the NASA Extragalactic database and the Simbad database to get the location information. So I think, say, like, click one of the Swift locations right up at the top.
Up at the top.
Yeah, pick
Ah?
one of those.
Oh, here we go.
Yeah, click around a bit and see if
Pulsar.
you can find one that's got a real image. There are a few in there on this.
Ooh,
Yeah, there you go.
we
So now, and then if you click the little thumbnail image,
Oh, that's
I love it.
it takes you to the NASA Extragalactic Database. Now here, everybody can see the high quality, very modern web Web 2.0 layout that the NASA Extragalactic Database has.
No comment. No comment.
Yeah.
But this is a very useful tool for astronomers.
As much as we are amused by it, it is absolutely fundamentally useful. It's a vast database of all the things we've looked at.
And it gets you to all the references. Yeah. That's really
Yes.
cool.
And then down at the bottom, there's like a proper schedule, so you can see the different
the actual
observations
calendar.
down there. Yeah.
Now Herschel is closing down, as I understand it, but there's still a lot of
I heard that.
blue dots. So
Yes,
they're
so it's still
observing.
working.
It's
Still
still
observing.
working. They're not
It'll
quite
be going
out
right
of-
up until the point where they turn the lights off and put the chairs on the table.
Well, this is cool. And you guys came up with this in 48. I'm just gonna play now. You guys get to watch me play. Oh, what's this?
So yeah, no, we had kind of a. So I kind of wanted to do this visual map.
Yeah.
And so I was kind of putting forward that we might want to do this kind of layout so we can actually see visually where everything is. But the guys I worked with were amazing. I mean, they're professional web developers. They were able to knock this stuff together in a ridiculously small amount of time.
Now you had 48 hours. You said you had most of it done by the end of the day?
We had kind of a working prototype by the end of the day. But then we had to, one of the things that has a huge amount of work in this is the database. So there's a lot of code on the back end which goes and talks to all the different telescopes websites, which all provide their data in all sorts of weird and wonderful data formats. With different conventions and different coordinate systems and all that. So a lot of the work actually happens behind the scenes, going and just collating all of that stuff and making sure it's like up to date and accurate. And all that.
Getting it in galactic coordinates in the first place is its own bit of code.
Conveniently, that was something I just happened to have knocking around.
That's good. Yes,
so that was fairly
everyone's got
straightforward.
that somewhere. However well it works is a different story.
I mean, who hasn't had to figure out galactic coordinates at some point?
Yes. Oh, well, that's really cool. So, okay, so then what else did you guys... So once you had the prototype working, you had this working, how was the judging process? What was that like?
Yes, that was fun. So once we had the prototype up and working, the actual judging process was at 2 o'clock on the Sunday, we all had to drop tools and stand up and do a 2-minute presentation. And we had one person presenting and one person working the computer. And we had somebody was there from NASA, somebody was there from an open New York public data group, and then we also had an actual real live astronaut. So Ron Garan was in New York to do the judging, and he's great. So those guys watched all the different presentations, and then there were a load of local prizes, like best use of different APIs, because people were doing all sorts of crazy stuff. Like they had quadcopters that they'd hacked the avionics of, so they could like automatically do grids around a room and use sonar to create a 3-dimensional map of the hackathon space.
What?
Yeah, exactly.
nice.
Completely mental.
Was this the hardware challenges?
Yeah, there were a bunch of hardware challenges.
Oh my gosh.
Yeah, so people were doing some amazing things. Another group took a virtual reality headset, which was one of last year's like big Kickstarters, because it does all your peripheral vision and everything. And then they created a game in Unity, which had the full terrain layout from the surface of Mars, where the Curiosity rover landed, and then they skinned it with all of NASA's photography of the Mars surface. There was an accurate representation of Mars in virtual reality that you could move around in.
Wow.
You could go and visit Curiosity, you could go and visit the lander. I mean, the kind of things people could put together in 2 days was amazing. And these were, in the vast majority, people who don't have a science background.
Right.
They're mostly like developers, engineers, data engineers.
I'm taking my glasses off. Sorry. I didn't put enough in. We'll try later. Sorry.
So yeah, all these guys just like, there were families who brought their kids, who wrote their first code on the weekend.
Oh my gosh.
It was amazing. It was a fantastic experience, and just to see all these people who had this enormous goodwill for NASA, who would just give up their weekends to come and just try and see what they could fix, see what they could do. And from what I've heard, this was true all over the world. All the different places where they held these hackathons had the same kind of stories coming out of it.
Yeah, so these hackathons, I've participated in a couple before. I am not a coder by any stretch of the imagination. I usually do a video project when I do something like this. But it's you're coming together. You may or may not have an idea even when you start, but it's that getting the creative juices flowing, getting people who've maybe not worked together working on something together. You have no idea what you're going to come up with.
Yeah.
Right, and that's kind of what it sounds like is happening.
But you have some you have some criteria. You said there were some special prizes and all, Jonathan, but did you know exactly how you would be judged, beforehand, or was it a little more vague as far as the goes?
Not exactly. It was, the criteria were, I think, quite intentionally fairly loose. They want to give people a very broad playground to play in to see what people come up with, and I think that was reflected in a lot of the challenge entries, and also some of the challenges. There's like a poultry farming challenge. I was, that caught me out a little. I wasn't expecting chickens.
Amazing.
Oh, there's my space. Yeah, there must be. I haven't. Do you have any idea of how many they came up with? There are several in each category. Some of them, there must be several hundred projects here that came out of it. Is there a... So
I think there was a total of, on the site they said there about 770 projects were submitted.
Wow.
So and that's just the ones that were completed, or to some extent. Lots of people over the weekend tried out things that were so crazy they didn't get to present them at the end of the weekend. That happens too.
That totally happens too.
But that's the nice thing about it. That's kind of the point.
So if you go to, I put the link in the comments, it's spaceappschallenge.org, and you go to projects, it's just the list of all the projects by category. And I assume like yours, a lot of these are just available for I think they have to be open source, right?
They're all open source. So all of the code for all of these projects is has been put on GitHub.
Okay.
So you can just go download the code, pull it down, play around with it. I mean, basically every single piece of code for our app is up there, so you can download the whole thing. If you can get Ruby on Rails running on your own machine or on your own server, you can pick it up and install it and play around with it.
Very cool.
And that includes the code for actually scraping from the telescopes. Okay. So for people who actually want to bring that telescope data together themselves, they can actually use our scrapers and build their own local database. Or
that also happens is you start a project and you realize someone's already built this piece, so let's put that in.
Yes. But yes, so we wanted to do something that was useful for scientists to actually look at the count of what's being seen. So up on the top right of the app, you can actually click a button which will download the data for you in plain text data.
Oh, there it is.
Yeah, I knew that would get you. But we also wanted it to be publicly accessible. So there's also a Twitter account which tweets when telescopes go and check out new locations. So if you check out the Twitter feed, it'll tell you that Herschel's gone to look at a new source, or Swift has just spun around to have a look at another location on the sky. And we'll also put out space news, telescope news when that happens. So when Herschel goes decommission, we'll be tweeting about that.
Yeah, it is SpaceCal NYC.
Yeah,
that's the Twitter
handle. SpaceCal NYC.
At SpaceCal NYC. Very cool. Yeah. What was your favorite other project that you saw there? Which one did you like the most?
There were some really great ones. I mean, I have to say,
we lost sound.
Quadcopters.
Oh. Sorry, we lost you down there. Go ahead, try again.
I was blown away by what these guys were doing with a quadcopter. Actually, just creating something which could navigate its own way around place, and then they also had some leap motion controllers to play with. So that's like an infrared sensor, so you can get your hand, and it knows where your hand is, and you can do very Minority Report stuff with it. So as you move your hand back and forth, you can control the copter. And then they had it doing barrel rolls and all the rest of it. But it was fascinating because we saw them starting out because they crashed the quadcopter into every single person. Because you're sitting there, you got your headphones and you're listening to music, you're cranking out some code to get this thing working, and in the background this quadcopter's whipping across the room and taking people out. So it was a little hard to concentrate at times, but no, it was phenomenal.
That's fantastic. Oh, I want to play now.
And then there was another group who did a great app. They actually put together a full game that you could play start to finish where you get to pick the elements in your spaceship. You get to decide what kind of power your spaceship's going to have and whether it's going to be manned or unmanned or where you want it to go. And they'll calculate the cost of building it and the time it's going to take to get from A to B. And there's really cute graphics. So you can kind of follow it through. And it's a great way to give people kind of a sense of what goes into building a space mission, what it requires to get from A to B. And the other thing that amazed me was the people who were writing this piece of educational software had literally just learned it that morning. Because they had no idea they kind of knew it was expensive, but they thought, oh, well, what should we build? And then they did the learning first, and then they built a really cool educational tool in effectively an afternoon and evening and a morning.
That's fantastic.
Oh, wonderful.
Yeah.
Have you participated in other hackathons like this before?
No, this was my first, actually. I've seen there's a lot of those kind of things going on in New York right now, so I wanted to jump in on one of them, and then the NASA one came around. I was like, yeah, I really have no excuse. I should jump in on this one. And I actually went back to the department and gave a talk to all the grad students and postdocs yesterday, saying, right, guys, seriously, next year, get on this.
So yeah, this is the second year they were doing it. So then
this is the second year, yeah.
It's going to be another one going on next year. So they're planning this as a yearly event then.
I think the official line is that they're just happy they all survived this one. There are only 12 people at NASA running an event for 9,000 people.
Understandable,
so,
yes.
So if
there are other issues
like
there.
To see this again, you should totally get in touch with NASA. Send them a tweet at Space Apps. They are listening. And encourage them that once they've recovered from this one, they should totally start planning for 2014. Because I think last year in New York, they had like 20, 30 people jumping on this. And this year, there were hundreds of people there. So next year, they're going to have to get a bigger space.
That's fantastic. Crowdsourcing, all the awesome. So your background is as a scientist. What can you tell us a little bit about what you do?
Yeah, so I used to do dark matter stuff. I used to do theory on dark matter, so trying to predict from our theories of our models of how the universe evolved, what we might actually be able to see if we made dark matter in the Hadron Collider 100 meters underneath Switzerland. Unfortunately, there was a slight hiccup with the Hadron Collider, and it's a small uncontrolled release of pressure, I think is what they called it. So the end result of that was, after a couple of years of very successful running and finding the Higgs boson, it's been shut down for a couple of years, and they're doing the upgrades, and then it'll be running at a much higher energy where they might hopefully find dark matter in a couple of years' time. Given the minor delay in looking for dark matter there, I got involved in astroparticle physics. So what that means is it's looking at subatomic particles, so the kind of stuff they're whipping around underneath Switzerland, but stuff that's been accelerated in stars rather than accelerated by our own colliders. And in fact, the stuff I'm looking at gets accelerated in other galaxies, in hugely powerful events in the center of other galaxies, like black holes, like bringing in a whole bunch of gas and dust and stars and spitting it out in huge jets. And those things fly across the space between galaxies, and a few of them hit Earth. And they're the highest energy particles we've ever seen. They're certainly a lot higher energy than anything we'll ever be able to accelerate ourselves, because we don't have an exploding galaxy.
We don't have a supermassive black hole
People are down on physicists making things like supermassive black holes in their backyard.
Safety goggles, guys.
If you've got your goggles, you'll be okay. So no, we get hit by these things, and they crash into the atmosphere above the Earth. There's about one of these per square kilometer per century, so they're super rare.
Wow, yeah.
And so to find enough of these things, you have to build massive detectors. So there's a detector down in South America. It covers 3,000 square kilometers.
Wow.
There's a huge grid of individual detectors, each one spread out by like 1.5 kilometers. And when the particles hit the atmosphere, they create a shower of particles, kind of the debris of the collision, which spreads over like a few kilometers, a few miles. And by detecting those when they hit the ground, you can figure out what the initial cosmic ray was and where it came from. And so we've got a few hundred or so cosmic rays at these energies, and a few 100,000 galaxies.
Yeah.
And my job is lining the few hundred up with a few 100,000 and figuring out where they came from.
Gotcha. So they usually get a pretty wide search radius, right?
Yeah, I mean, it's kind of So the detector has an accuracy of the order of a degree, which is, it's not too bad. There aren't actually that many galaxies very close to us, and the flux from the galaxies drops off pretty quickly. So we would expect to see the nearest, brightest galaxies predominantly. Unfortunately, unlike light, cosmic rays don't go in straight lines.
Yeah,
so
particles having mass.
That's the thing which kind of screws us up, because they have charge. So when they go through the galactic magnetic field, they get bent around. So one of my colleagues at NYU put together an amazing model of the galactic magnetic field using things like how light gets distorted when it goes through magnetic fields to effectively X-ray the magnetic field of the galaxy. So that was very handy. He just gave that to me, and I said, thank you very much.
I will acknowledge you in my paper.
I know. 5 years of research, full PhD thesis, and he gets like the citation going, cheers, that was great. And that's the wonderful thing about science. You get to build on these amazing projects that everyone else does, and they all put them out. It's the heart of open source. Everybody gets to use everything.
Right.
And so with that tool, we can backtrack all these cosmic rays through the galaxy and see where they would have hit the galaxy. And then we can actually try and line them up with other galaxies and see which ones of our nearest neighbors are firing cosmic rays at us, and hopefully identify what it is that's accelerating them. Because we've no idea what the actual engine is that produces these things.
Right. Yeah, it's so I know we're straying away from education a little bit, but that's something I worked on a while back. Was looking at the radio jets from these. Actually,
cool.
Back there.
Yes.
Look at the radio jets, and yeah, for as long as we've been mapping and measuring, and some people say, oh, AGN or old hat. It's like, no, we really don't know how those jets are being launched, or we really don't know the underlying physics, and it's a fascinating problem.
Yeah, and it is kind of cool to be able to work on things which are the only physical things we're ever going to get from other galaxies.
Yes.
It is quite amazing. And these things were spat out millions of years ago, and they've had a very long journey to get to us.
Right.
That is impressive.
Yeah, so these hackathons, not just for the public as well. I know within astronomy, there's been a couple of things like this. This is how I met you, is through Dimitri Muna, who I met at Dot Astronomy, which is runs a similar thing. So if you're actually an astronomer, there's hackathons that go on at Dot Astronomy conferences. They've started doing them at American Astronomical Society conferences. So the last day of the meeting, we all hole up in a room and make stuff. Which is
by the end
really
of AAS, you haven't lost enough sleep.
Exactly. I think it was only like an 8-hour. It wasn't a full 24 hours, so it wasn't so much the lack of the sleep. Like when I was at Dot Astronomy, there was a lot of lack of the sleep. Yeah. And again, you don't necessarily have to be a master coder to do this. Somebody with a science background, or somebody with an engineering background, or in my case, I do zilly videos.
Yeah, and this was the thing that really surprised me, is that a large number of the people who were there had no coding experience. They were designers, or they worked on kind of user interface design, or they were literally wandering around and like taking live video and putting together videos of the hackathon. And the actual submission process for the global thing is we had to have a 2-minute video. Right. So you've got all these like 7 guys who, let's face it, we're coding geeks and scientists, and then we've got to put together a 2-minute like audio-visual presentation. That's not really in our compass.
Quick, find another person.
I know, what do we do now? So there were young people there too. Is that right? Okay, because there's got to be some of these for kids, right? Or just for any age,
it was great, and there was so there were families with kids there. Like I think one of the youngest we had like 8-year-olds running around, getting involved in these things. I mean, so one of the challenges was like a Lego rover project. Yeah. Where you could create a fully automated robotic Lego rover. Now,
Legos, yay!
I have nephews that could have knocked that out the park.
Yeah, I think I do too. I've got 3 nephews. They probably could have done quite well.
Yeah.
That's awesome.
Exciting.
Yeah. Do you know of any other non-space hackathons coming up that people could get involved in?
Yeah. So at the moment in New York, there's something called Big Apps, which is a New York City open government styled hackathon. So New York is very in favor of open government, making a lot of data open. So they've released huge amounts of government data. out for free. So you can, for example, you can just download every 311 call and pass that. So like somebody made a map of Manhattan in complaints, like to figure out who complains about what. You know, what the Upper West Side complains about, what the Upper East Side complains about, you know, what bankers complain about down in Tribeca.
I always rage about how politics doesn't have enough of a foot in data. This is the data.
Yes, and so they're running this. It runs, I think, until June 8th, and they're running lots of independent individual hackathons during that time. And unlike the NASA one, where you get glory, in this one you get cold hard cash.
Oh, okay. Well, yes, I guess they can afford it.
And so a lot of these things are sponsored by people like AT&T or other companies that actually want to get in and start using, like, just really, it's crowdsourcing good ideas. And there's a bunch of companies that get spun off out of these hackathons. So if you come up with the best solution, then you've got kind of a proof of concept. You can then go on and show that to people, and the company will come along and say, actually, we'd like to take that further.
That's awesome.
And I guess we got the equivalent of that out of the NASA one, because the European Space Agency that were running the old defunct MySpace Cal have been in touch this last week saying, hi guys, so we kind of like your solution.
We use your code.
Could we have that?
And it's open source, so
I know,
you say
exactly.
sure.
So we're going to be chatting to them and seeing if we can get that shunted over to their servers, unless of course NASA wants to take it, so we can start a bidding war between the NASA and the European Space Agency.
Sad bidding war.
Totally
both trying to
totally open for bribes. I could be bought with a Magnum.
I was going to say, we could be bought with chocolate, maybe?
Yeah, totally. Ice cream.
There you go. There you go. Yeah, I highly encourage hackathon. I haven't done any of their contests. It was more like for fun. Let's see what we come up with. It's just a fantastic way of working, meeting new people and creating and finding interesting things. I think somebody did a 3D video from one of the rovers on Mars, Spirit or Opportunity, one of the older ones. Made a 3D YouTube video. You put on your 3D glasses, you're wandering around on Mars. You know, like they did that in 8 hours.
That's
it's just amazing stuff that people come out with. And like you said, really useful stuff like the NYC big apps. Something that's actually useful and socially responsible.
Yeah.
So pretty cool.
And also, I think hackathons attract a certain kind of person. So if somebody's giving up their weekend to do this kind of stuff for free,
there's something wrong with them to start with.
Exactly.
Really interesting people.
Run like the wind.
They're one of our people. It's all good. Awesome. So I know you had another interest, another side hobby job type of thing, which has nothing to do with science education. But I am a geek, and I wanted to ask about it since you showed it in the little pre-show. You were also an illustrator, a map illustrator, for.
Yeah, so on my evenings and weekends, I do maps of imaginary worlds. And so last year I ended up doing the maps of Game of Thrones. So I did the Lands of Ice and Fire, which is a map book of 12 maps that covers all of Westeros, all of Essos, all the way out past Karth to the far lands of Ashai. So I spent a substantial portion of my weekends and evenings last year buried in Westeros. It was a lot of fun, but in total it's 72 square feet of maps.
Wow.
It was a lot of map.
Wow. Yes, the Lands of Ice and Fire. I'm gonna put the link because Dimitri actually sent along the Amazon link. I'm just gonna share that because that's fantastic. Or at least this is for the poster. I don't know if it's the same thing.
So it's over on Fantastic.
Yeah. Oh
Maps.
yes. No, I see. I see
yeah.
you. Yeah.
So my site for the map stuff, and not my physics stuff in any way, is over on Fantastic Maps.
Okay, because it lists George R. R. Martin as the author, and no, it lists you as the second author. I was like, wait.
Yeah, there is a bio.
Yay! That is so cool.
Which does not mention physics.
How long have you been doing that? The maps. Has that been a long?
So I've been doing bits of drawing for a long time, but I guess I started working properly on. I actually put together a formal company to manage it last year. When I picked this up. But yeah, I've been putting stuff up for free. And for the gaming crowd, they like a lot of maps, so there's a lot of maps out there for them. Yeah. And then I started getting work for authors and a couple of other bits and pieces. And then, Random House came in, and that just like knocked me out for 4 months.
Oh, that's so cool. How did you balance that with doing your science as well? Did you get a lot of leeway to work both projects?
No, I did full days in the office, and I did full evenings on my maps, and after 4 months I apologized to my wife.
Okay. Yeah.
Yeah.
Sounds about right. At least you weren't a grad student where you're expected to be doing your work days and nights. So you at least had the night.
There's nothing left.
Yeah, I just about managed to juggle that one. That was not so straightforward.
That's cool. Well, I have a birthday coming up, Internet, so it's on my wish list now. So that is really cool. That. Anyway, there's nothing to do with science education, except that,
None whatsoever, except there's a certain crossover, I think.
A lot of us watch Game of Thrones, let's be honest.
It is pretty amazing. I mean, they're doing a wonderful job of that series.
Yeah.
Or read the books, right?
Yeah.
Yeah.
I heard about the books from my friends in grad school who insisted that I read them, and I was like, I don't really like fantasy, and they finally got me to read them when the show was coming out.
Yeah.
And we left the office on Sunday night and went to go watch it at someone's house. The one person with HBO.
Yeah. Yeah, it's like what people used to do when one person in the town had a color TV.
Yeah. Yeah, we're doing it. We're going back, at least for a certain age group of us, we're going back to that. It's like, I only have Netflix, I don't get TV anymore. Can I come to your house?
Yeah. But yeah, Game of Thrones is, it's great, but I wouldn't say it's widely family appropriate. So my parents are like, oh, this show that's on TV, that's the thing that you were doing the maps for, isn't it? It's like, yeah. Oh, we should totally, I'd like to read the books. I was like, yeah, probably not. I'm not going to recommend those to my mum.
My little brother actually started reading it. He doesn't like books, but he loved the show so much that he actually picked up the book. I was so excited. I was so happy.
Right.
So
doing for people in their 20s what Harry Potter did for late
early
teens.
Seriously. All right, cool. Well, I want to thank you for coming on the show and talking to us about this hackathon and all the other cool stuff you do.
Well, there is global judging, which starts on the 3rd to the 7th. So that vote will be conducted on Twitter.
Oh, it's a public process.
If you're up for throwing in, so they have NASA judging for the prizes, but they have a public vote for the public's choice. So if you're interested in this kind of stuff, go through, check out the videos. Everyone has 2-minute videos now on their site, so we'll have to have a 2-minute video in 9 minutes time, or they're not eligible. But go in, check out. I mean, this is a worldwide thing, so there are applications from the Middle East, there are applications from Africa. I mean, really go on, see what people have made, and if you like what they did from the 3rd to the 7th, throw your vote into the hat and pick the public vote. Because the people that win, apparently, one of the possible prizes, you might get to go to Kennedy and do space training.
So cool!
Awesome!
Jealous!
Oh, fun.
I'm not seeing on the website, I do see the map where they actually had participants on all 7 continents. There's somebody listed at McMurdo Station who participated in it from Antarctica. So go That's cold amazing. Person. Go really cold person for joining. But yeah, I'm not seeing where to, but I will look that up afterwards and share that out so that you guys can.
Yeah, I think the vote will start on the 3rd. I'm not sure they've put out exactly how that's going to be conducted yet, but we've got a couple of days till that starts.
Okay.
So I shall be whipping votes on the 3rd.
Awesome.
See what we can do.
Awesome. That's so
cool. Good luck.
Yes, good luck. Yeah. We've got Guido hooked already. You can comment that it's a dangerous time sink. He's already hooked. So
also, I'm telling you, if you are a member of science faculty, you should be looking at this kind of thing and thinking for next year about a challenge that you can submit to engage people with the kind of research you're doing and see if you can put together tools, get people to put together tools which open up the data that you've been working on.
This is just another way for people to be engaged in the scientific process, and
that
is something we are big on.
Yeah.
So, yeah.
No, I think it's a great example. I'm really glad NASA's taking it on. Very
cool. Very cool. Well, thank you so much for joining us.
Thank you for having me.
Thanks,
that was
Jonathan.
Lovely.
Great to meet you and hear about it.
Yep.
And thank you everyone for watching Learning Space today. Sorry the canister thing didn't go so well. I think I needed a bigger chunk of dry ice, so maybe I'll try another day. That'll be next week's demo.
That's science.
Yay, science! I'm still working on scheduling next week's speaker. We're going down the list of people that we've asked so we'll have a bunch more shows coming up. This week we have, today's Wednesday, so tomorrow's Thursday, Planetary Society has their hangout at noon Pacific. Friday at noon Pacific, we have the weekly Space Hangout, which is hosted by Fraser Kane, and all of us sit around and talk about the biggest space stories of the week. And I think actually we talked about this app challenge last week. We got that in the show. Sunday night is a virtual star party. We have our astronomers who have amazing backyard telescopes and totally spoil us with amazing views of the cosmos. So check that out on Sunday nights as well. And Astronomy Cast on Monday. I think that's the whole weekly lineup. So thank you everyone for joining us.
Very cool.
Thanks.
Goodbye.
Bye. It's not an official science experiment. Oh gosh, it's really cold. But be safe when you're doing it. I think that's the lesson I want people to come away with. What ends up happening with the story with the Florida teenager, I don't know what's going to end up happening. But there you go. I will share a link about that in the comments. And I'm going to set my film canister over here. I'm sure the mic will pick it up. So thank you to Dawn and Sean for getting me dry ice and bubbles. So, you can find dry ice in a grocery store usually. That's where I've always found it.
I'm impressed that they got the dry ice that quickly.
Yeah.
They did. Well, of course we're at a science building, right? So
I know, but
Every
still.
science building has dry ice.
we have a
You
cooler.
gotta, like, go upstairs and things.
We were told we could go and get it from ice cream shops.
Yes,
Ice
that's
cream
another
shops
place.
have dry ice. That's a good place to get dry ice.
That's another place to get it too. Yeah.
In our case, we were using it to make a cosmic ray detector.
Ooh, you want to tell us about that? That sounds cool.
Yeah.
Oh, how do you do that?
So actually, it's surprisingly simple. So what you do is you get a sheet of metal, and you put it on top of a tray that's got dry ice in it, and you turn a big plastic box upside down over the top. Now, inside that box, you put a sheet of fabric on the bottom and a sheet of fabric on the top soaked in alcohol. And what happens is the alcohol gets into the air inside the box, and the fact that you've got the dry ice on the bottom cools it down, so you get this kind of super condensed gas inside, but it's still transparent. And then when a cosmic ray comes through, just like an airplane going through the air, it causes condensation. So it creates a vapor trail for the cosmic ray in the air, and you can actually see cosmic rays passing through the box. It takes about 5 minutes for the gas to condense to that level, but then you can see all these little cosmic rays coming through. And if you
you can do lots of things with dry ice that demonstrate how the pressure changes when something goes from a solid to a gaseous form. And there are various ways of doing that safely and unsafely. I've been around at least one very unsafe demonstration. Don't ever use glass. Don't ever use glass when you do this. But I did find a little, we have a whole bunch of these plastic film canisters. Do you guys remember film?
They are hard to find.
I know you guys do, but I'm sure somebody watching
No,
is like,
but they're so cool and useful, and they are really rare. So.
can keep a lot of little SD cards in that container.
ooh, that's brilliant. I never thought of that. We don't tell Dawn.
A
We have a
retro
lot
photo
of
store.
Yeah, we have a lot of these here in the. I live here in the STEM Resource Center on campus, and so we have a lot of odds and ends like that you can play with. And I have a glove. I have this nice little rubber glove thing. You don't want to touch dry ice with your skin. That makes for badness too. And you can see what happens when you take a little piece of dry ice. The problem with the gloves is, of course, hard to pick things up. And I use this when I do demonstrations of what comets are made of. It's really fun to mash this up into a powder, add water and dirt, and you have a comet. It actually outgasses just like a comet would. So can you see that? I don't know how good the resolution is.
Yeah, no, you can see that.
I can see it.
Yeah.
So hopefully on the YouTube stream you'll be able to see that too. And so it's outgassing, and I'm going to put it in the little plastic container and put the lid on it and just, set it aside and see what happens. But I also have
Later.
Sean came over with this lovely gooey liquid, which I'm pretty sure is soap and water.
It looks green. Is it green?
It's green.
Greenish.
It is green.
Okay.
I think it's soap and water, but you can also, when I'm not doing comets, I usually have a little bottle of water on the side, and I'll drop some dry ice in the water, and you get stereotypical picture of science. So as it's outgassing, you get the gas and also some crazy bubbles. because there's a lot more soap in here than I realized there was in the first place. So you're showing changes of, this is why I have a big plastic tray too. You're showing a change in the state of matter from solid to gas. This is called sublimation. Teach this to your third graders. They will go home and tell their parents and be very proud of the word they learned. And yeah, and you get your stereotypical picture of science right here. You can put a little bit of dry ice in drinks, just don't actually drink it for that cool smoky effect. A lot of people do that around Halloween, and this is actually going to bubble over, isn't it?
It's not bubbling over too quickly, though.
No, I think Sean measured out the right amount here.
I don't know. Just...
So dry ice, fun to play with, but be safe, goggles, glass. And if you're going to do an explosion, do a tiny little plastic explosion like this guy. So we'll sit here and wait. Oh, I can feel how cold the plastic is. We'll wait for that to explode. I'm sure that'll scare the pants off of me at some point. I'm going to leave my safety goggles on until that happens. And don't actually
You have it aimed properly.
I do, as I'm holding this piece and pointing the other piece away from my face.
Okay.
So, you know.
We'll look forward to that. Yes.
Be curious, play around. You know, do science even when... Hi everyone, welcome to Learning Space. I'm Nicole Gallucci. I am postdoc with the CosmoQuest Citizen Science Project. Joining me this week is my co-host Georgia Bracey.
Hello.
Hello. Georgia is the formal education lead for CosmoQuest, and we have with us Jonathan Roberts.
Hey there.
Hey, who is a postdoc and also one of the recent winners of the Space App Challenge, which we'll be talking about in a few minutes. First, I actually put together a very last-minute hands-on demo. Today I've been following the story of a high school girl in Florida by the name of Kiara Wilmot, who has been arrested and expelled for doing a somewhat dangerous science experiment on her school grounds. And there's a lot of speculation and stuff surrounding the story, people saying a lot of things. But from what I can tell, it seems like, you know, she did something not terribly good, not something worthy of a felony. And, you know, official science experiment or not, I say, play with the science, let's go. And to do that, I'm going to make a little explosion in here, but try and demonstrate some proper safety techniques while I do it. So first of all, I've got my safety goggles. So if you're going to play with anything that's going to make a boom, wear safety goggles.
Because they're cool looking.
Very fetching.
They look almost as cool as my Google Glass is going to look, right?
Exactly.
Okay, a little dorky.
Getting ready for those, yes.
I'm getting ready for that, that's it. And I have one of my favorite substances to play with in a plastic bucket here. So I have some dry ice. Ooh.
Very nice.
Yes.
Happen to get your hands on an actual radioactive source, you can stick it in, and it looks like a big spiky Christmas tree because all the cosmic rays, all the radiation goes at a given distance and then stops. So if you have like an alpha source, it goes like 2 centimeters, and then it just stops.
Cool.
You see all little vapor trails coming off. It's really cool.
Okay, we're doing that.
Yeah.
We're totally gonna do that.
Do we have the radioactive source here?
Wow, went over that. But we do have cosmic rays. Maybe
Everyone
less
has
so in the
cosmic rays.
basement, but
Cosmic rays are totally democratic. They'll hit you wherever you are.
yes, they will. Even in my basement office.
They will, even in your basement office.
So is that a cloud chamber? Is that what
Yeah.
is that another? Okay.
That's a homemade cloud chamber.
That. Never made one though, but same thing. Okay.
If you have a link for how to do that,
yeah, I think we knocked together. We put together a proper thing for it because it was done for a science for non-scientists course here at NYU. So we did it with all of the undergrads.
Cool.
I'll find the link and pass it over.
Excellent. So that'll be an even more impressive demo. I'm out of dry ice.
Yeah, that might be one you want to get up and running well before you start.
Yeah. I'm gonna put a bigger chunk in. Woo! Science. All right. So let's talk about the main point of the main topic of the show. You want to talk about Space App Challenge,
Yes.
which went down. Oh shoot.
Oh, you don't want to hear that in your science experiment. Isn't that what you want?
Actually, you can feel
Wow.
it too.
Okay, that's pretty great.
That's more what I had in mind.
I'm getting distracted. This happens. Okay,
Well, this is every day for us.
This is every day. Welcome to science. Oh, and before I get distracted again, I want to remind everyone watching, if you want to comment or ask a question,